Thank you. Hi everyone. I'm Philipp. I'm part of our infrastructure team, so I do lots of internal tooling, and then I do many conferences and meetups. And today we're doing trainings, so it's whatever comes along. And today I want to kind of explore like how do you actually monitor services. So normally we're a bit abstract, like we don't have the final solution. It's more like, okay, yeah, you have all these building blocks, and you want to kind of build something. And we always say, yeah, you can totally do that, but it's up to you. So how can you do that? Yeah, we've seen that. And that was kind of the starting point for the general talk, that everybody needs to do microservices right now. And thanks to the distributed nature, stuff is not getting any easier. And luckily, we have kind of a solution there, and we start to have all the building blocks in place. So we can just try to explore how that might work. So we kind of want to log all the things basically. Um, and as my common question, like who is all using all the hottest stuff like microservices? Anybody? Or kind of? Yeah, everybody is so kind of. Um, but let's say you have more than 5 servers and you want to kind of keep track of that and monitor. And as soon as you have a few servers, you probably don't want to use SSH plus tail anymore, because that is not going to be fun. So how do you log? Like there are lots of solutions. There are kind of more product focused ones, and we have kind of these building blocks. And now I try to put together these building blocks in more or less an interactive fashion. I've just tried to set up the demo today. We ran into some new interesting issues. We can start debugging live. We can start discussing. So this is not slide driven. This is pretty much just hands on to see what is going on. So let's start to build something. I have one very simple Spring Boot application just because I'm a Java developer and it's kind of the easiest thing to get started with, but it doesn't really matter. And I also say this kind of is a stupidly simple application, so I'm not using any of the fancy Spring Boot mechanisms. You totally could, but it would just make it more complex and it's not really the point of what we try to achieve. So I'm not doing any discovery, any load balancing, any security. I'm basically just calling stuff and try to monitor what is going wrong. You could add all that complexity, but it will make everything just more complex. And we'll try to keep it simple. But we have some moving parts already, and we'll try to see how that goes. So who is using Java in general? Okay, that's a few. If you're not familiar with Java, there's this ongoing debate between JE and Spring, and nobody really cares. You just build stuff. I'm more on the Spring Boot side because it's kind of the easiest way to get started. So what they have is they have a web page called start.spring.io, if I remember correctly. And there you just say, I want to have a project. And in the dependencies, you just say, what do you want? Do you want web, security, any other dependencies? And it will kind of put together a curated form of all the libraries that work well together, give you same defaults, and you only have to write like, I only wrote 10 or 15 lines of code, and everything else was kind of put together for you. And then you just can run that. It has an embedded Tomcat server, so you don't have any dependencies. It just like get a jar file at the end and can run it. So that's what I'm using. But we're not going to dive too deep into that unless anybody's interested. And I will run that on LightRail. Anybody heard of LightRail? It's one of the 100 plus services AWS is providing by now. LightRail is kind of the cheap service. They don't have all the bells and whistles, but they're priced, I think half a gig of memory costs €5 a month. And I'm just starting 3 of those instances and shut them down in the evening. So it basically costs nothing. Our base image is Ubuntu 16.04. Doesn't really matter that much. And I'll just put everything together. To use the Elasticsearch, we have cloud. So I have my Elasticsearch instance there and the Kibana instance. And I will just throw all my traffic on that instance and visualize it with Kibana on cloud. Yeah, everybody I guess knows the stack. I've not added Logstash because I don't need it in my configuration. So I'll just pretty much have some beats running. They will forward traffic into Elasticsearch, and then we can display it in Kibana or wherever it makes sense. So what I'll do is I will just package stuff, we'll deploy it, and we'll run it. I've done the packaging and deployment already. We could do it again. It's pretty quick. The dependencies are like 20 or 30 megabytes, but I never try to rely too much on the Wi-Fi here. I've got my own internet here. That's hopefully working. So let's see how that goes. So let's throw away the slides and see what is actually going on here. So I have 3 instances that are running, and I just start something that is doing something bad, or just to show you what with bad I mean. I have a Java application, and you can guess what this is doing. This is my Java application. Any guesses what this is doing? Yes, it's just generating basically garbage until it runs into an out-of-memory exception. So it's pretty much the standard Java application. And I will, let's make that a bit bigger. And no, I don't need you. I'll just throw that out. Now I need to find the right instance where I have that running, or actually it doesn't really matter. We can just connect to the right one. So I'll just SSH into my instance front end. And now I will just start my Java application. So I do Java, I'll give it an XMX of 512 megabyte, and I'll start my bad jar. So before we do that, we kind of want to monitor instance. And the goal is I want to see what is going wrong here. So in a few moments, I will just start the bad jar. It will run until it runs into an out of memory. And at the same time, we will open up Kibana. I guess everybody is familiar with Kibana and the dashboards we have by default. So the dashboard I'm interested in now is the process dashboard. I just want to see my processes. And we will just add auto refreshing. So I'll set that to refresh every 5 seconds. We'll scroll down a bit, and here we have our resource usage. So you can see this instance is using, I don't know, less than 35% of its memory, and this one less than 15%. And this looks pretty stable at the moment. And we'll just run the bad jar and see if anything changes. So that is running, it's running in the background. Let's see, on which instance is it where we started something. So soon we should see something, I hope. Come on. Yeah, we see something growing. And you can see we have lots of processes. I could have stopped the other processes since we have already something running for 20% of the memory here, which is Java. So you can see Java is eating away my memory, basically. And this will now pretty much just grow and grow and grow until it crashes at some point. Like I think that this runs for half a minute. And then it will crash, and then you can see it kind of returns to the previous level. So that is a very nice way of metric beat. I've just installed the agent and forward the system metrics to see how my system is behaving. And from that thing here, you can pretty much tell something is wrong and something is just eating up my resources. Let's see, is it still running? Can actually check the process. Yeah, it's still running. This one is holding up well. So my process should keep growing here. Yeah. And give it another half minute or so, and then it will crash eventually. And you can see the CPU usage is also spiking here. So something is seriously wrong on that instance. So if you just were using top, this would be super annoying to find, and would not be recorded, because as soon as the process has crashed, everything would be back to normal. So yeah, here the process just tells me, okay, it doesn't even run into the exception, it was killed before that. But now everything is back to normal, and if you would just run top, it would A, be pretty cumbersome to find that in the first place, and B, any record of it would have been, or would be gone. But thanks to Kibana and Elasticsearch and Beats, we have kind of recorded that. And you can see, okay, something was wrong here. And then you can start debugging like what was actually wrong with my process. Okay, next up, I already have a Java process running. This is basically my Java process. It is not doing too much interesting stuff. But what you can do is you can call it. So everybody can grab their phone and just go to that URL. Because what we're basically doing is I call frontend.xera, that is my Twitter handle and everything, which is a rod13 of my last name, .wtf/good. So if you run that, it should actually give you an OK. I hope you can read that. But making it bigger doesn't help because it doesn't make the input field bigger, unfortunately. But if you're there, frontend.xera.wtf/good, you should get a good, right? Anybody manage to get an OK? Yeah. What happens if you do run /bad? You should get a white label error page, so it will tell you 500, something went wrong. Or you could do something like foo, and then it shouldn't find the page, and it should tell you, okay, you have a 404. So you can just generate some traffic, and your application is running, and you don't really know what is going on. And you want to see what is happening with my application. And we have another very nice project that is PacketBeat. And the nice thing, thanks to PacketBeat, is you don't need to instrument your application in any way. You can just monitor the network traffic and collect what is happening on the network interface. So I'm monitoring port 80 here, and I'm just collecting the traffic that is just running around on port 80. So let's jump back here. I can pause that one. And we can go to PacketBeat. Let's go to the overview. Who does not know PacketBeat? Okay, there's quite a few. So PacketBeat is quite similar to Wireshark. The problem again is if you have lots of servers running Wireshark on all of them, then getting the output and then combining that is kind of painful. So you don't really want to do that. PacketBeat is kind of made for making your job or life easier. It's just running on all your servers. It's using the same base library, libpcap. It collects the header information and extracts meaningful information from that. And since it's just on the network, you don't need to instrument your application. So it will read the network headers and it will know, okay, this was an HTTP request and this was the response for it. The whole thing took 100 milliseconds. The response code was a 200 and the URL you hit was good. Or the response code was a 500 and the URL you hit was bad. And we're extracting all of that. So this is just a general overview of all the transactions. I don't have a database, I don't have a cache, and I don't have an RPC system here. You can see some web transactions we're running here. You can see the latency in general, error and success rate, very weird curve for the percentiles. Like first everything was okay and then kind of degraded. And then you can see the errors over time, like, oh, we got lots of HTTP errors. So probably we should check out what is going on HTTP. So switching back to the web transactions here, or switching over there, it will tell you, okay, we had like 30, 35 web transactions here. In total, it was 81. And we have lots of 500s. So 29 500s on /bad. That is kind of expected. We had 15 on /good. We had a few on foo. Then somebody was on an Apple Touch device and tried to access the Apple Touch or the /fav icon. I can tell that the Swiss audience is very serious because most people just try random URLs and see what happens. And at some point they show up. You can see nobody sent me any messages. It's just fun, like, because sometimes people try to send like messages or try to write something obscene or just add something to the presentation here because, well, it's all live. But you can see all of that information has just been collected by PacketBeat. We didn't even connect that to our application in any form. It was just collected when running in the background. Okay, that was packet beat. What else do I want to do? Let me quickly check my notes. We've run packet beat. Oh yeah, since we have triggered errors, we probably want to collect these errors. So what you normally get is, if you get an error message, yeah, and I have a broken pipe, so I don't see the output here. So that is not as stable as I would wish. But let me quickly check var log apps front and oops. Oh, I don't have that file. Let me check var log apps front end. Why are you empty? Huh? I'm just confused. Whoa. How can that be? Okay, never mind. Let's kill the Java process and start it in the front again to collect the errors. Or actually, let's see if I'm just confused and we actually got some errors here. So if I'm switching over to FileBeat, is everybody aware what FileBeat is? So FileBeat will just tail a file, send it over the network, and collect it. So FileBeat here is running multiple things. If I switch over to type, you can see we have log and we have Java app. And obviously, I don't know from the top of my head where my Java app is configured, so I can look into the configuration. etc FileBeat. Oh, is that slow? Yeah. And we have var log apps something JSON. So there should be a JSON file in that directory. Otherwise, we would not be able to collect anything. That is interesting. Anyway. Oh yeah, and now we have the front-end JSON. For whatever reason, I didn't see that before. That is where my log file is actually ending. And normally you would get like proper like old school log lines where you have just all the different fields and you need to parse them separately. But that is not really great to take apart, because then you need to write the regular expression to actually get all the different fields, see the user, the error level, what was the actual error message. Especially multi-line statements with stack traces are a pain to parse. So you don't really want to do that. What I'm doing instead is I have switched my logging to JSON already. So I have a JSON file and I can just send that directly into Elasticsearch. And that is what we have collected. Just to show you what that looks like, it's that one. So here, even though it's very hard to see, we have something like it starts here, and I think it goes until the very end. So this was one of the bad URLs you hit, and the highlighting is very hard to see. But what we actually have is I'm just throwing a runtime exception in my application. I'm not doing anything fancy. So as soon as you hit the bad URL, I'm just throwing a runtime exception with the message, my bad, something went wrong. And we have collected that with some other information. So you know in which class the error happened, what the severity was, when the error happened, and all of that. So we have that in JSON, and we can directly collect that with FileBeat into Elasticsearch and have that stored centrally. So if you have lots of different applications, you can find them easily. And we're also collecting log. This is basically the logs of the host system. So who is accessing anything? Are there any error codes? But we'll start off with the Java application. So I will filter down to my Java app here. So when you click the little plus sign, it will filter down to the Java application. You see we have 38 hits for the Java application. Let me check. I'm only interested in the errors. So we only had errors here. So yeah, let's filter down to that as well. And then we can just open up one of these. And here you actually see that was the entire error our application generated. So you know it was my Java application. You can see it was the front-end app. Every app would have a nice name. It will just output that. It catches like the root cause and like what actually went wrong, and you even have the caller, and you can see the stack trace, like how did you actually get to that place where your exception happened. So we're just collecting all of that information. You do not need to do any heavy parsing. It's just collecting the JSON output and storing that in Elasticsearch. So you can just monitor everything, and it's not really any further work. Next up, what we can do is we can ping the application and see if it's up or down. For that, we have added Heartbeat recently. Have you ever talked about Heartbeat? Not really? Okay. So Heartbeat is basically a pinger. So it will ping any endpoint you have. It can do HTTP, ICMP, HTTPS, some other protocols. It will ping something and will report back how is that service doing. So I have stopped that process now, because otherwise it would generate all the like too many requests, and it would kind of you would not see our own requests. But we can actually start that process again now. That is running on its own monitoring instance. So I can say I want to log into that instance, and it's pretty much a very simple configuration. You just say what is the endpoint, and you capture that result and store it in Elasticsearch. So I can simply start that, sudo service heartbeat start, and it will start pinging. So if we go back to our dashboard for HTTP, if everything is working as expected, we should see a rise in requests, because I think it's by default it's pinging every 10 seconds. So right now it's 19, and I would expect, since I guess nobody of you was that, we will get a very stable number of requests here of pings from the Heartbeat service. And we can switch to the Heartbeat index. And there is no Java app here, and there is no severity here. Once we have disabled that, you can see these were the heartbeats that are running. And it's actually capturing some information, like where was it running, what is the round trip time, what was the IP, what were we pinging, what was the port number, how long was the resolve time, etc. That is all very nice, but the dashboard would be nice. Luckily, we have built the dashboard already, so all the dashboards I'm showing are just the default dashboards. I'm just using them. I have not really done any hard work here. So you can see here we are pinging one service. You could add as many services as you want to ping. You can see, okay, it's up and running. It's all up. And here you can see, for example, what is the response time. So you know what the response time is on the TCP level, on the HTTP level. If you're using HTTPS, it will tell you what the SSL overhead is and the DNS resolution. All of that is combined here. And at the bottom, you can even see a heat map, like how long are the requests taking. Like most of them are very fast. Just one here was pretty slow.
How much control do you have over the requests you send? Can you configure them completely, like send a post request?
No, I don't think we are support post. Yes, I can repeat the question. Like, how closely can we control the requests that we're sending? So as far as I know, it's currently only a GET, right? In Heartbeat. So yeah, not that fine grained. You can do stuff like authentication, like basic auth, and HTTPS, but that's pretty much it. So it's just pinging something.
A lot more stuff is coming.
Yeah, but I know there are lots of discussions, but we'll see in the long run what's happening. Yeah.
Can you hook your own scripts to it in a way, so you can bypass that and post in a way?
Can you hook your own scripts into that? I don't think so. You could hack the Go code and kind of customize that and compile it yourself. But as Nicola said, there is more to come. There are lots of ideas. There's lots of things you could do. Actually, the history of Heartbeat was that our own cloud service wanted to have something to ping its own services. And it was kind of close to what we were already doing with the other beats. So we thought, well, this is easy to integrate. We'll just add that and run it. And so we built the Heartbeat, and we'll probably expand it to other use cases as well now.
You could add quite easily your own modules, which you script.
Right. And let me quickly kill my process so I can actually show what happens when the process is down, which you're pinging. So we should have a Java process that is called front end. So let's quickly kill that. I hope it's dead. Let's see. Like it should switch in 15, 20 seconds probably. It hopefully switches from up to down. Yes. And we let it reload 2 more times, and then you should just see service is completely down. And here you have pretty fine-grained or like nice data presentation of, you can see when was it down, when did it come up again, and further down you could see like that information obviously will stop now. You will not get any meaningful information on the connection times anymore once it's down. But you can at least very easily tell like which services are up and which are down. So yeah, unfortunately, that service is dead now, which is not great. Let's restart it so we can do some other fun stuff with it. So I'll just run that again, and I don't need sudo. I'll not just need java jar opt front and jar. It should start up in a few seconds. For Java applications, it's actually pretty snappy. So yeah, like the colorful output and the ASCII art, that is all what Spring Boot gives you. And at the end, it should just tell you, I started up in X seconds. Nothing more to add here. Okay. One other thing that is nice about Spring Boot is that it is exposing some HTTP endpoints, which you can just collect to show what is up with the service. So let's switch to curl to actually do that. So you can just call curl xget. Is that large enough for you? HTTP frontend .wf. And we have health. If I didn't mistype anywhere. And it will tell you, yes, service is up or down. It tells you what the disk space is, and yeah, not that much more. And we also have metrics, which tells you more stuff. It's not that nicely formatted, unfortunately, but it will tell you like how much memory did you collect, what is the heap space, what are the current garbage collections. So you can get kind of some inputs for that. We are currently discussing that it would be nice to have kind of a generic solution to collect that. But in the meantime, somebody wrote a custom beat to collect just those 2 endpoints, which is called Spring Beat. So for Spring Boot, there is Spring Beat to collect that. Unfortunately, there is no release yet, and you need to compile it. And it's all built on master, and I think it's just broken now. I found the commit which changed stuff, and it's not working quite the way I want it to work. But I can show you what it's actually doing right now. So I have it here. So it's oh, come on. No. Okay. One SSH connection lost. We can stop that one again because we don't need it anymore. We can switch into the right directory. Opt go. So this is the typical Go setup, and I just have. So you just have some Go code. I ran a Go build, and it generated a Spring Beat binary for me, and you can just run that. And to run that, we can say Spring Beat. The config file is actually springbeat.yaml -e. So we want to see something, and now it's running. And it should send some metrics to Elasticsearch. And you can already see like this is built on master. So this is 600 alpha. and there is no tag or release or anything, and it's just pulling in all dependencies from master as well, as far as I saw, and it currently broke because the mapping is not applied correctly anymore. So I will have that information in Elasticsearch. We can actually switch to the DevTools, and if I run cat indices, like you can see, oops, that is not helpful. Those are all the indices we have. So we have Spring Beat here. I can actually just show you what is in there. Unfortunately, the mapping is broken, so we cannot easily visualize anything in Kibana now. But just to give you an idea, get search. Oops. No. Match. Did I mistype anywhere that my completion is broken? No. Match all. No, not now. Yes, I did mistype somewhere. Yeah, of course. Yes. And then you will see it's just collecting that information. So you have this space, all the information that is collecting, and you could build some visualization based on that. Like, for example, heap is always kind of critical in Java applications. You could easily build how much is the total heap size of your application, and then you could fire some more requests against it and see, is the heap growing or is it stable? Are you leaking any memory? So just exposing some of these metrics and collecting that and then visualizing it, you can see what is going on with your application and is it behaving the way you expect or not. And one more thing that is kind of very interesting, especially if you have a distributed system, often you have something that is slow. And since it's distributed, it's very hard to know what is actually slow. So what I have done in my application, I have added a call that is called call. Those who have still the link open can call it if they want to. So it's called call, and it will call multiple methods internally, and there is a random sleep in there to simulate that one of these methods is slow. So at some point, it might take, I think, up to 2 seconds or so. It will tell you hello world. So call is basically calling another method, hello world, and we now want to know which one of these is actually the slow one. And there is a general tool out there to help you trace these calls. It's the Open Tracing project. So what you basically do is whenever you get a request into the system, you give it a unique ID. And you will keep that unique ID over all the requests internally. So you know this was one call. And then there is something called a span. And the span is always basically one method call. And that gets another ID. So you know, okay, this method call took that many seconds and this method call took that many seconds. And then there is a server component called, so the Java part to actually add these IDs to your application and send out that information is called Sleuth. Sleuth is like, I think it's very British and a detective. And there is a server component that can take these results, store them, and actually visualize them. And that is called Zipkin. And there's a component, so you can just add Zipkin to your Spring Boot application and run that. And I have my my Zipkin server running here. So let's just get rid of that. It's running on my default ports. So let's see, everything since 8 o'clock until 9:30. Find all the traces in my system, and those will be ordered by slowness. And you can see show 10 of 10 since I have the limit on 10 traces, and you can see, okay, that request took nearly 2 seconds. So what is going on here? Let's take a look into that. That was the slowest we had. Like there was another one, 8 seconds, 5 seconds. Let's see what was happening here. And then you can see there was something called call that took 1.9 seconds. and something that took just 4 milliseconds, and that was home. So our method call is calling home, and home was fast, but call was the thing that was slow. And thanks to that visualization, you can actually very easily see which part was slow and trace it, and then you can start debugging, like, why was this part slow? And the nice thing is, Zipkin has multiple backends where it can store data. By default, it's in memory, but it can also store data to Cassandra or Elasticsearch. So as soon as you have the Elasticsearch integration then there, so you can store all of that information in Elasticsearch for pretty much the all-around view of your application. So that's kind of all the stuff we did. If you want to run more Spring Beat endpoints or metrics, like there are more, which are currently not collected. So if we have kind of a generic solution, we could just collect all the endpoints, like as soon as something is exposing JSON, you can just collect that and see, okay, which beans do I have actually in my application exposed? Or yeah, what mappings do I have? Can I shut down my server? Give me some traces, anything like that. So we have run that, we have seen that. And that is actually, you would see that in the Java application as well, but we can show it on the slide. This is what you would log with Sleuth. So you see, I was talking to my front-end application. Then you have the trace ID, and then you have basically the call ID. And I want to send that to Zipkin at the end. I think that the next slide is broken down again. So you have the trace ID, that is kind of, if you do a call, the trace ID will always stay the same over one call. And then you have the span ID, that is basically a method call. So you know what was one method call and what was slow and how was it put together. And we're sending that to Zipkin and collect that. Yeah, we've seen that. It's very easy to visualize. Stuff we're kind of missing at the moment. So one thing I would really love to have in Kibana is annotations, where you could add in Kibana, I have deployed my application at this point, have it kind of a marker in the charts. So you basically, I don't know, you do a REST call and you add one document and you have this marker, and then you see here you have deployed something, and suddenly you see the 500 grows or the 400s, or you see them decline. But then you really know, okay, this was a good or a bad release and something changed here. So that would be really nice to have this whole application monitoring if you could annotate that in Kibana. One other thing, I have pretty much automated the entire demo now with Terraform for the cloud part and Ansible to configure my services. The only thing I cannot configure right now is our cloud service because it doesn't have a proper API, or we don't expose the proper API. Otherwise, we could include that into Terraform, and then I could really automate the entire demo. So I have, like, from the DNS setting to the creation of the keys to the servers, everything is automated. Yeah, installing the services, just not our cloud service. So yeah, they know they will add it at some point in the future. One other thing that is coming up pretty frequently is that people want kind of roll-ups. So today you're storing everything in 10-second intervals, but maybe next week you only care about 1-minute intervals, and in a month you only care for 1-hour intervals, because you don't need those fine-grained metrics anymore, and you want to store save on the disk space and probably have faster aggregates as well. There's something we're talking about, like we know the need for it. It will hopefully be added at some point in the future. No guarantees yet when it will come, but there will be something to kind of aggregate the data and take less fine-grained or coarser-grained time spans and aggregate those over time. So let's see if we get those anytime soon. And another question I recently got was, when will there be a Zipkin plugin for Kibana? Because it would be really nice. You can see all the dashboards and everything in Kibana directly. But for the traces, you still need to switch over to the Zipkin application, which runs somewhere else. And I don't think we're trying to build that yet, and I haven't seen anybody try it, but I think it would be totally possible to build a plugin for Kibana just to show the information. Since you have it in Elasticsearch, it's just only a bit of visualization work. Yeah, and I'm always interested in, like, what people are thinking, what is still missing, both in terms of monitoring your application, what would make sense to monitor in addition, and what would make monitoring kind of easier in general. Yeah, conclusion, once everybody has left. So we've seen we have the application and the environment, how we set up everything. So that was pretty simple. Then we were monitoring the system and the network as well. We now have the FileBeat modules, so monitoring stuff like Nginx or the operating system is also very simple. We have collected the application logs. The ideal approach is if you have JSON already or something that is structured, that would be very easy to collect. Like if you need to parse anything with regular expressions, that is way more painful. But in most frameworks, it's pretty easy. You have some kind of JSON logging output, so you can just configure that and do that. You ping your services with Heartbeat for uptime. You can collect application metrics. Right now, it's the kind of more or less custom Spring Beat, but hopefully we'll soon have something that can collect any endpoints. We'll just have a get beat or whatever the proper name is. I'm sure Nicola will come up with.
There is an HTTP.
Yeah, there is another community beat, which is an HTTP beat. I'm waiting for an official solution now from you, but
He plans to contribute to it.
yeah.
Same for Spring Beat.
Okay, yeah. So probably we'll have kind of all the tools under our stewardship and readily built binaries and proper releases at some point, so we don't need to compile Go code. And yeah, request tracing is something very interesting. To most applications, it's pretty easy to integrate by now, but you will still need that Zipkin server and the Zipkin visualization to show it at the moment. Though you can store the data in Elasticsearch, actually. And I think that's pretty much it. Any questions?